There. Today we're going to take a look at implementing infinite scroll pagination in a React Native app from scratch. I'm going to show you how you can implement pagination using a MongoDB database with a Nest.js backend and React Native on the UI. In the end, you'll be able to implement an infinite scroll pagination for a collection that has over 5,000 documents in it. And we can see here, you can freely scroll, ask the server for additional records, which is pretty much essential in any modern app if you want to load data quickly and then be able to continually paginate as the user scrolls along. So let's go ahead and get started. Before we jumped into the video, I just wanted to thank everybody who has subscribed to my channel. We recently reached 1,000 subscribers, which is a huge milestone for myself, so thank you to everybody who has subscribed. If you haven't subscribed already, I invite you to do so. I post at least one video a month and take requests from you guys. So the next video I'm going to be working on comes directly from a request from Ayub down below, so thank you, Ayub. We're going to be making a video about Nest.js pipes, interceptors, and middleware, and what the difference is between the three. So if that sounds like the kind of videos you want to see, please do subscribe. Okay, so before we go ahead and create our directories for our backend for infinite scrolling, we're going to need to import some data that we can actually use in our backend and display on our UI application, so we can actually implement the scrolling. So to do this, MongoDB, the MongoDB team, actually provides sample data sets online that you can download and restore freely into your local environment. So I'll paste these commands in the description below if you want to copy them. But all this is going to do is take a dump of the sample data, the archive file. And then once this finishes downloading, we can go ahead and restore it to our local database. So after it's finished downloading, we'll see that we have a sampledata.archive file in our directory. And we just need to go ahead and run mongorestore, pass archive flag, and set sampledata.archive. Now, I already have this data imported, so I'm going to see duplicate errors, but you should be importing this data into your local database. So after launching MongoDB Compass, you can see I have these sample collections created here, and we're going to work with the sample supplies collection. And inside this, we have a sales collection, and it's a collection with a list of sales. Because we have such a large number of documents in this collection, in this case 5,000, it's not feasible for our UI, in this case the React Native app, to ask for the entire data set at once, but instead we want to just ask for perhaps the first 25 or 50 documents, and then as the user scrolls down, more of these documents will be loaded to the UI. And this is what our infinite scroll pagination will allow us to do. It'll make loading the data very fast for the user when they first open the application, and as they scroll, we keep asking for the server for additional documents from this collection. So back in our VS Code editor, I'm going to go ahead and open up a terminal here, and I'm going to use the Nest CLI to generate a new project, and we'll call it Infinite Scroll Backend. Okay, with the Nest installation finished, I've gone ahead and cd'd into the newly created directory, so infinite scroll backend, and now I'm going to use the CLI to ask it to generate a controller, and this is going to be our sales controller. So the CLI has generated the controller for us. It's created the class, decorated it with the controller decorator, and it's gone ahead and added it to the app module. So now in the sales controller, we're going to go ahead and define our route to be able to obtain the sales from the MongoDB database. So I'll add a get decorator to specify that we want to just make this at the root URL for sales, and we'll have an async function called get sales. Okay, and this is going to take, so this route is going to take some parameters that we're going to need to pass to our database in order to accomplish the pagination that we want. In particular, we have two properties that we need the client to provide us in order for us to know which segment of the database or the collection we want to send back in a given request. So let's take a better look at these. I'll create a new folder called data transfer object, and I will create a class called pagination parameters.dto.ts. Okay, and this is going to be a class. So the first one of these properties is going to be called limit, and this is going to be a number. And the other is skip, which is also going to be a number. And what these properties are going to correspond to are, in the collection, we're going to have the client tell us, for a given request, how many sales records should we limit the database search to, and beyond that, how many documents should we skip before returning that particular subset of sales from the collection. And this will become more clear as we work through the example, but for now we're going to need these two properties. So we can actually take advantage of a package called class validator in order to add some validation to these parameters. So I'll go ahead and add class validator. Okay, so now that we have class validator installed, I'm going to add a decorator called isOptional, which goes hand in hand with the next validator we'll add called isNumber. So what this will do is it'll check that if limit is provided, it is a number, and is optional because the client doesn't have to specify it. So we'll do the same thing for skip here, which makes sure this is a number. Now, because of the nature of how we're going to use this class in our controller, we'll also have to transform it, because by default Nest.js doesn't do this for us in a parameters DTO. It would only do it for a body. So on for import transform from class transformer, and we can go ahead and install this class as well. And now in transform, we're going to be passed the value. So this will be the limit in our case, which is going to come in as a string because of the nature of how this query param will be parsed from the URL. And we want to make sure it gets turned into a number so we can use it when interacting with our database. So we'll call number.parseInt and pass in the value, which just transforms the string value into a number. So we'll do the same thing here. We'll just copy this to the end and paste it down here. So now limit and skip, when they are passed in, will be turned into a number. So there's going to be one more thing that we have to do in order to have this class validator perform validation and transform these properties for us. If we go ahead and open up the main.ts file, in our bootstrap method, we're going to call app.useGlobalPipes. And we're going to attach a new validation pipe. And this constructor takes an options object, and we're going to pass transform set to true and save. So now, if we go ahead and open up Postman and query localhost 3000, we're going to get back an empty array as expected. But now if we add a query parameter of limit and skip and set each to any number, and fire off this request and then look at the logs we're getting, we can see the pagination parameters with a limit and skip that have been transformed into a number. So now back in our sales controller, I want to go ahead and create a new service, sales service, that will be able to take in these parameters and talk to our underlying repository or database to get the sales based on these query parameters. So we want to separate this logic out into a service and keep it out of the controller. So we'll add a new injectable class here called sales service. And we'll have an async method here called getSales, which will take in our pagination parameters from the controller. So in our app module, make sure we add the sales service to our providers array. So now that in our sales controller, we can add a constructor and add our sales service. And inside of our controller method now, we can just simply return this.salesService.getSales, pass in the getSales parameters, and in our sales service, we'll change the return function here to be a promise. This will be of type any for now, and we'll just return an empty array. So now that we have our sales service, we need to prepare our application to work with our MongoDB database. So I'm going to go ahead and add Nest.js / Mongoose, and then Mongoose itself. Mongoose is the ORM, or the third-party utility we're going to use to interact with our MongoDB database. And now in our app module, we'll go ahead and in the imports array, we'll call mongoose module dot for root, and this is where we can pass in the connection URI. So in our case, for localhost, it'll be localhost, and then we can specify the database that we want to connect to. So in this case, we know that's going to be sample supply. So we'll call sample supplies. So now that we're successfully connecting to the local database, we're going to go ahead and create a schema file, which will define the shape of our sale and allow us to interact with the underlying data from MongoDB. So I'll create a file called sale.schema.ts, and this will be decorated with the schema decorator from Nest.js Mongoose. So export a class called sale here, and this is going to actually take an options object where I'll actually specify the version key set to false, because I don't want to deal with versioning right now. And by default, MongoDB will take the name of the class and lowercase it and pluralize it. So this will create a collection. In our case, we already have a collection called sales. So now we go ahead and define the shape of the data that exists in our database. So we'll add a prop decorator for each one of these properties. First of which will be an ID, which we know is an object ID. So I've gone ahead and added properties for each one of the keys in our document. So we have an ID, sale date, items, store location, customer, coupon used, and purchase method. Each one of these is decorated with the prop decorator, and I've kept the types for the arrays and the object customer object as any, just to save some time for now. So now that we've added the sales schema, I'll go ahead and actually create a sales module, which is what we should really be doing here in order to keep things a bit cleaner and to separate things out. So we'll have a class called sales module, and we'll add the imports array, no imports yet, and then we'll move our providers array over. So we have the sales service and the controllers, we have the sales controller here. So now in our app module, instead of declaring that there, we can remove these guys, and then in the imports array, we will import the sales module. So go ahead and clean that up a bit. So now in the sales module, we'll also add an import here. We'll call the mongoose module for feature. And this takes an array of schemas that we define. So in this case, we have the sales schema we just created. We'll provide it the name. And then for the schema, we'll call schema factory create for class, and then pass in the recording schema, and then pass in the sale schema we created. Okay, so if we come back into our sales schema, we actually want to change how we're defining the object ID here from Mongoose. So I'm going to actually go ahead and import schema as mongoose schema from Mongoose, and now instead of an object ID, we'll pass in mongoose schema.types.object ID, and this will make the compiler happy because we're using the correct type. And then also, Mongoose isn't going to like us being able to pass in an ambiguous type here, so any for customer and items. So we could define sub-documents or sub-schemas for these, but just to make things a bit more simple, I'm just going to remove these properties since we actually won't even use them on our UI. So now we're ready to create our sales repository, and this will be the class, an injectable class that will be responsible for interacting with our sales collection and then getting the sales. So we'll export a class called sales repository. And inside we're going to have a constructor, and here we're going to use the inject model from Nest.js Mongoose, where we pass in our schema. So our sales schema, pass in the name, and then we can add the sale model for the name, which is going to be of type a model, and we'll pass in the sales schema. So this will allow us to actually work with the underlying collection. And then make sure that this is a private and read-only, so that it's a class variable. So now we can actually implement the logic necessary to retrieve the sales from the database. So I'll have an async method here called getSales. And this will be a function that returns an array of sale documents. And importantly, we're going to be able to take in those pagination parameters from earlier that our controller received. So we're going to use those when returning documents from our collection. So if we wanted to just get every sale in the collection or the entire collection, we could simply return this .sale model and call find with an empty filter. And this is just going to look up and get every document in our collection. And if we had a small collection, this would work perfectly fine, but since we have about 5,000 documents in there, it's unrealistic. Now, to actually use these pagination parameters, we're going to pass in an empty object as our second parameter, which is just the projection. So in this case, we want all the fields back, so we'll send in an empty object. And then the third parameter here is another object, which is an options object. And here we can specify the limit and skip from our pagination parameters. And I'm also going to add another property called lean, which if we take a closer look, just make sure that Mongoose returns the document as a plain JavaScript object rather than a Mongoose document, which is what I want in this case. And then we can simply spread our pagination parameters, which will take the limit and skip and add them to this options. So let's go ahead in our sales module. We will add the sales repository to our providers array. And then in our sales service, we can now inject the repository we just created. And now in our getSales method, we can return this .sales repository .getSales and then pass in the pagination parameters. And we can also change our type here to be an array of sales instead of any. And similarly, if we go back into our sales controller, we can change our return type here to an array of sales. Now there's one more thing we want to add to our find method here, and in our options array, I'm going to add a sort property, and we're going to actually sort on the sale date and specify that we want the most recent sales first. So we'll pass in a -1 to ensure that, make sure the documents are sorted before we skip and then limit them. And this is to ensure that we always have the correct order when we are getting the correct pagination, which is important to get the correct results back. So if we fire off this request, we can see we're actually only getting back a single sale now instead of the entire collection, which is what we'd expect because our limit is set to 1. If we up this limit to 3, we can see we're now getting back 1, 2, and 3 documents. And if we were to skip, we can see that the order will now change. And one more quick thing, if you wanted to test out the validation we have for the query param, if we send off this request, we actually see our validation is working properly. Okay, so there's going to be one more piece of functionality that we need to add to our backend in order for us to have pagination work. And that is, we need a way to tell the UI or the client how many sales records we have. So we need to get the total count in order to properly use pagination, because we need to know once we've reached the end of the list and no longer have to ask the backend for more records. So in order to do this, I'll add another get route here, and we'll call this count, and we'll make a new method called count sales in our controller, and this is going to return a promise type number, and we'll return this sales service dot count sales. So let's go ahead and go into the sales service and implement this method. So we'll have count sales in here. This will return a promise with a number, and we will reach into the sales repository and ask it to count the sales, keeping our logic nice and separated. So in the sales repository now, we will implement the actual logic here, count sales. We know this, of course, is a promise as a number, and we're going to return this dot sales model dot count. And we're just going to return an empty filter because we want to count the entire collection. So now back in Postman, if we fire off the request to our sales API and ask for the count, we get a number back. This is the 5,000. Okay, so now we're ready to go ahead and initialize our React Native UI. So to do this, I'm going to open a new terminal and type in React Native npx React Native init, and then you can name it whatever you'd like. I'll use infinite scroll UI, and then I'm going to use a TypeScript template. So we can use TypeScript, and we'll go ahead and let this setup finish. Okay, so now that we've initialized the React Native project, we have the infinite scroll UI folder. I'm going to cd into that and then make sure I reuse yarn start to start the React Native bundler, and then also make sure, of course, we have our backend running in the infinite scroll backend. We have yarn start dev. Okay, and then separately, I'm going to go ahead in the infinite scroll UI in my finder here in the iOS subdirectory. I'm going to open up the infinite scroll UI.xc workspace. And this is going to go ahead and open up Xcode. And after opening up Xcode, I'm going to go ahead and select a simulator I want to run the app on. I'll use the iPhone 12, and then we can hit the play button to build the app. Okay, so first things first, I'm going to open up the infinite scroll UI folder. And in the app TSX, I'm just going to go ahead and pretty much remove all of this boilerplate content. Now to set up our components, I'll go ahead and create a new folder called source, and this is where really all of the source code for the project will live. And within here, I'll create another folder called components, and inside of these components folder, this is what it's going to make up our components, or our list of sales that we want to render here. So within the components folder, I'll create another folder called sales list. So this will be our list of sales. So inside of here, I'll have a sales list.component.tsx. And this will be our sales list component. So we'll import React from React. And then we'll export sales list. It'll be a functional component. And for now, we will simply just return an empty view with some text in here. Sales list. Now if we go back into our app component, let's actually render the sales list, and we can see our sales list text appear. Okay, so now in the sales list component, we need to be able to actually retrieve all of the sales from a server and then render a sales list item for each one of those. So in order to do this and to keep things clean, I want to abstract the logic behind retrieving the sales, the paginated sales from the server in a custom hook, so that we could reuse that functionality beyond just this component. So inside of our source folder, I'll create another folder called hooks, and this one I will call use get sales.ts. So this will be just an arrow function called useGetSales. And inside of this function, this arrow function here, this is where all the logic behind retrieving the sales and storing them for the current page will reside. So we're obviously going to need some state in here to store the sales that we've retrieved from the server. So to do that, we can take advantage of the useState hook from React. So we'll have an array here of sales, and then we'll have set sales. So this will be useState. And we'll pass in an empty array to start with here, but we want to be able to specify a type for this to take advantage of the compiler checks. So what I'm going to do as well in our source folder, we'll create a new folder called DTO, which stands for a data transfer object, and we can store our interfaces for what comes back from the server in here. So we can have interfaces. So we can have an interface for requests and response, which we'll use the request in a second here. But for now, let's just define our response folder. And in here, I'm going to define the shape of the data that comes back from the server for a given sale. So I'll call this saleresponse.dto.ts. And we're going to export an interface here, which is sale response. And this is just an interface which defines the shape of the sale that comes back from the server. So we know, of course, we're going to have an ID, which is a string. We're going to have a sale date, which coming back from the server is of course going to be serialized as a string. So now if we come back into our hook here, we can actually provide some type information for our use hook here for use state. So we know that this set sales. So we know the sales here will be of type sale response, and this will be an array of. Okay, and to start off, I don't want to actually implement the pagination logic yet. I just want to, first of all, make sure we can get data back from the server and display it in our component. So to do that, we'll start off with a useEffect hook, which will run right when the component is mounted or when this hook is first called. And when that happens, we want to reach out to the server, get the initial set of sales, and then set them. So to accomplish that, I'm going to define another arrow function in this useEffect hook called fetch and set sales, which will be an asynchronous function. So inside of here, we'll have a const, and I'll call this fetched sales, and we'll call it wait and use the fetch API. And here we can specify the API URL. So in this case, it's going to be running on our local host, port 3000. We know from the Postman request we sent earlier, it's going to be /sales. And to make sure we don't get back every data set, and to make sure we don't get back every sale in the collection, for now I'm just going to specify a limit of 5. And by default, this is going to use the get method, so we don't even need to specify that. So once we have the sales, we're going to want to parse them. So we'll call fetch sales, and maybe it actually makes sense to call this sales response. And then we can call sales response.json, and of course this is asynchronous, so we're going to have to wait here as well. And what this will do is convert the raw HTTP response we get from the sales response and extract the body. And what we really want is just the JSON or the sales objects themselves, and that's what this will do. So finally, we can call set sales and pass in the parse sales. And now in our useEffect hook, when this first runs, we will actually call fetch and set sales. And now inside of the hook, we can actually return the sales. So now in our sales list component, let's go back in here, and we'll use destructuring here to get the sales. We'll call useGetSales. And let's just log out the sales that we're getting to make sure that we're doing everything properly. So if we log out those sales and then take a look at our logs, we can see we are getting this data back from the server properly, which is great. So now let's just render this initial list of sales we get, and then we can take a look at implementing pagination. So to accomplish this, we're going to use the flat list component from React Native, which allows us to easily specify an action or a method to execute when we reach the end of a list. In that case, what we're going to want to do is ask the server for additional items. So let's go ahead and set that up. I'll include the flat list here. So it needs to know the data to pass in. In this case, it's sales. It's the sales that we've retrieved from the server. And then it takes an additional parameter called render item, which will actually display the component based off of each entry in the sales array we have here. So to do that, we're going to need another component where we can actually display an individual sale. So inside of the sales list folder, I'll create a new folder called sales list item. And inside of sales list item, we'll have sales list item.component. And I can just copy the boilerplate JSX we have from the sales list and change this to sales list item. We won't be retrieving the data and it won't be a flat list. So for now, we can just return an empty view. Remove these imports we're not going to use. And now we can specify the props that this component expects to receive. So in this case, sales list item props, we know it's going to receive a sale item, which will be of type sale response as we set up earlier. So we can provide some type information here, pass the props in, and now we can destructure to actually get the sale. So let's output a bit of information about each sale. So let's say we want to know the store location. We'll call sale and then access the store location. Okay, so now we should be outputting 3 pieces of information for each sale. We'll export it. And now in our sales list for our render item, we can extract the item, which we'll call the sale. And inside of the render item, I will output the sale list item. And of course, this is going to require the sale, and we can just pass that directly into the flat list. And of course, make sure we actually return this here. And there's one more prop we want to provide for the sale list item. That would be the key, so that the list can identify duplicates. So in that case, we'll pass in the sale ID because we'll know that's unique for each sale. So now if we refresh, it looks a bit messy, but we do in fact have a list of each of the sales that we are returning from the server. So just to make this a bit cleaner, we can add a little bit of space in between each one of these. So in the view here, I'll add a style prop, and I'll just give a little bit of margin, maybe 40 pixels for each of these sales. So now we're correctly rendering each one of the sales. And just to demonstrate that our server is working properly, if we wanted to go back into our hook here, or use get sales hook, and maybe we wanted to up this limit to 30 and refresh, now you see we're getting 30 sales from the server. So now comes the question, okay, how can we do this automatically so that the user, as they scroll along, keeps asking the server for more records? Let's implement that next. Okay, so the next thing we want to do is actually determine how many records we have in the entire list, and we'll see why this is important in a little bit. But so first, let's actually declare a new const here, and this will be the sale count, and we'll have set sale count. And so we'll use state again here, and of course this will be a number. We'll just pass in 0 to start with. And so this variable here, of course, is going to represent how many sales we have in the entire collection, and we'll make use of the endpoint we set up earlier to obtain that information. So I'll declare a new const here, just an arrow function called update sale count, which will be asynchronous. And inside of here, we're going to reach out to the server. So we'll reach out to the server. We'll call this sale count response, and we'll use fetch again. We'll reach out to our API at port 3000, we want the sales and then the count of the sales. So now to get the parse sale count, we'll call a new const parse sale count, and then we'll await the sale count response.json. And lastly, we can set the sale count to the parse sale count we've just retrieved. So now instead of retrieving and setting the sales in our use effect here when the component first mounts, I'm gonna uncomment this or comment this out for now, and then simply just call update sale count. So now when the component first mounts, it's gonna update our sale count, and I want to write another effect or use effect that will react to the change in sale count, because really if the sale count ever changes, I want to update our list of sales, because I really want the sale count to be kind of the single source of truth for when we need to reevaluate our list of sales, rather than just when the component first mounts. So I'll have another use effect here, and we'll say when the sale count is modified, and importantly, I want to check to see, okay, if the sale count doesn't equal 0, because if it's equal to 0, we don't need to do any work. But if it's not equal to 0, and in that case, I'm going to want to reach out to the server and do precisely what we've set up in this original hook. So I'll uncomment this section out, and we can remove this hook entirely. And I'll paste it back here. Now we have fetch and set sales. So inside of our use effect, we'll call fetch and set sales. And then now we're going to want a use effect that runs when the component first mounts. So we'll have no dependencies, and then update sale count will get called. So what's happening is with components first mounting, we're getting the sale count, setting it, which then triggers this effect to run to fetch and set the sales. Okay, so the most important piece of implementing this pagination is going to be able to implement some sort of function that will reach out to the server in increments or pages, and then update our sales with each of those results from that current page. So to see what we mean, let's define a function called get next sales. So what this function will be responsible for is retrieving the next page of sales given the current page we are on. So it'll become a bit more clear as we flesh this out. One more thing we actually want to add before implementing this is actually just a loading indicator to indicate when we actually are in the process of retrieving the next page, because we don't want to be in a situation where we call this function multiple times. So we'll have a use state here, and by default this will be false because we're not loading to begin with. And another piece of state we're going to want, as I alluded to, is the current page we're on. Okay, so we'll have a page and then set page, and the page is going to inform us about what our skip and limit variables should be when we reach out to the server. So to start, the set page is simply going to have a page of 0. That's the first page we're going to be on. So in get next sales, the first thing I want to check here is that if the current sales dot length is greater or equal to the sale count, and so this is important here. So I want to say and the page doesn't equal 0, or we already are loading. Then I just want to return we're not going to get the next page of sales. So what this Boolean is saying here, or this expression is saying, if our sales length is already greater or equal to the sale count, we don't need to reach back out to the server, so we're going to return early. And importantly, we don't want this to occur when the page is equal to 0, because when the page is 0, it's going to indicate that we're kind of resetting our whole pagination. And we'll see what this looks like in a second. But for now, the important piece is that we don't want to get more sales if our sales length is greater or equal to the sale count. Hopefully that makes sense. And then additionally, if we're already in the process of loading or getting the next sales, we return. So the first thing we want to do is set loading true, so that if this function is called more than once, it won't reach out to the server more than once if we're already loading. So I'll have a const here, and this will be called next sales. Okay, and this is going to be the fetch call that we originally have here. So we'll have the next sales response, and we can simply copy the fetch call that we've already created. And let's change this template literal to a template literal here so we can include some variables. Okay, and what I want to do is declare two variables that we're going to include in the URL. Of course, is the skip, and we're going to have a limit, as we know. Okay, and the limit's always going to be a constant value. It's going to be the size of our page, right? So this can be any value you want. The page size is going to be how many records are loaded initially, and for each time you reach the end of the list and you ask for more records, how many records should come back. And the bigger page size you have, the longer it will take to retrieve, but it'll mean you have more records to scroll through before reaching back out to the server. So I think a reasonable page size here will be 25. We'll just declare some constant up top. Okay, so our limit is simply just going to be the page size, and then the skip itself is going to be the current page we're on times the page size. So what this is saying is, so if we're on page 3, for example, that means we've already gone through 75 sales. So we want to multiply 3, or page 3, times our page size, 25, gets us to the 75th sale, and that's where we want to start off on for the next page. So hopefully that makes sense. And now in our URL here, we can actually include the correct limit. So, and the skip, of course, is the skip we've just set up. And I also realized I've just set this to set page up here. Of course, this should be use state. Okay, so now we have the next sales response, and of course we're going to want to parse this similar to what we did down here. So let's just go ahead and get the parsed next sales response, and that's going to be the next sales response.json. And now here's where the page comes into play. I'm going to check to see, okay, if the current page is 0, in that case it will be. If we want to perhaps refresh the list, I want to set the page back to 0 because we want to reset everything. So if the page is 0 and we just got the first result set back, we can simply just call set page and pass in the parsed next sales response. Otherwise, what we need to do is merge our existing sales array with the incoming new records for the next page. So we'll call set page, and in order to do this with updating or merging array values in React, we're going to get a function here where we can get the current sales and we can return the updated value. So we're going to want to spread the current sales, and then we will spread the parsed next sales. And also make sure instead of set page, actually we want to, of course, use set sales here. So set sales and then set sales. So if we do that, the compiler is now happy. And the last thing we want to do before exiting this function is set the page. So now the page is going to be equal to the current page we're on plus 1. So next time that we call this, we'll move on to the next page, and we'll set loading to false. So now instead of fetch and set sales, we can get rid of that entirely. And down in our use effect, where we react to the sale count changing, instead of fetch and set sales, we'll call get next sales. And I'm going to just disable this React use effect ESLint, because I don't want to have to wrap this in a use callback. Things will work properly as they currently are set up. So off the bat, if we just simply refresh our simulator, we can refresh it. We can see we are in fact getting the first 25 sales, which is great. And now we need to inform the flat list that when we reach the bottom, we want to reach out and get the next set of records or the next page. So let's go into our flat list, our sales list component. And the flat list exposes a prop for us called onEndReach, where we can essentially call a function to tell our component or our app that we've reached the end of the list, get me more records. So to do this, I'm going to go into the useGetSale hook, and we're actually going to export this function, the getNextSales function, altogether. So we export getNextSales, and we can import it here, destructure it, and now we can simply provide getNextSales to onEndReached. So now if we start scrolling down our list, we can see that we are in fact getting this awesome pagination, this awesome infinite scroll, where as soon as we reach the bottom of the list, you can quickly see the list update in real time. And in fact, instead of the coupon used here, I'm going to actually pass in the ID so we can actually see that each one of these records are unique. So let's go ahead and refresh this entirely. So you can see we're getting unique records back. Okay, and one last feature I'd like to implement is refreshing this list. So when I pull to refresh, I want the list to completely update. So how can we go about doing that? Let's go back into our useGetSales hook, and I'll create a new function called refreshSales. This will be asynchronous. And inside of here, we're going to do three things. First of which, as I talked about earlier, we're going to set the page back to 0 because we want to reset everything. We're going to set the sale count back to 0 because we want to refresh this list. The sale count could have changed, so we'll set it back to 0. And then lastly, we'll just call update sale count again. And what that will do is it will call update sale count. We'll set the sale count with the new value. Of course, our hook here will execute, so getNextSales will be called. And this is where this additional logic will come into play, because we didn't reset our sales list. We don't want to have this list kind of flicker, disappear when the user refreshes it. We want to maintain the records we do have. So that's why we have this page doesn't equal 0. And then down here, when we get the sales response, we can say, okay, was the page set to 0? If it was, let's reset the list entirely. So let's see this in action. I'm going to export the refreshSales function. And then back in the sales list component, I am going to specify another prop here called refreshControl. And we can use the refreshControl from React Native. And we can specify some props. So one more prop we're going to need actually from the useGetSales is the loading indicator. So we can tell the refreshControl when we are loading. So we have refreshing prop, pass in loading, and make sure we destructure that here from our hook. And then on refresh, this is the actual callback we're going to call. So we want to call or destructure, of course, first refresh sales, and we'll call refresh sales. Okay, so now if we save this, we should see that we were able to pull and refreshed. And so what that will do is reset our list. So if we scroll down and we see our infinite scroll working, our pagination working great, keep on going. Okay, now you can see the length of the list here is quite large. We're on probably page 8 or 9. It's a lot of records. If we pull to refresh, our page gets set back to 0 because these records are all newly refreshed from the server. This is pretty much infinite scroll done on the UI. So I hope you've learned a lot from this demo project. If you have any questions, please leave them in the description. I'll do my best to help out. Thank you, and I'll see you in the next video.